All right, lesson 29. We're going to talk about random walk today, and we're going to use it in terms of maybe not as theoretical as we could possibly get, because there's a lot of probability type stuff in there, but we're really going to focus in on the way to use it to solve problems, right? So, in our random walk, we're gonna go into a casino. We're going to start with about a amount of money, and we're going to randomly walk around until uh, we either gain a certain amount or we lose all our money, and then we kind of figure out um, or we use the random walk in order to figure out some of the things that could happen to us in a casino. So if you remember, for this exercise, we're going to build a class called a random walk. So you'll see it down here. We're going to talk about the attributes and that and whatnot in a few minutes. But in this example, we're going to say, I don't know, we're either at a roulette table where you can get a 0.473684, and that's if you have two green spaces in your roulette table. I think that's the one that you'll see in the board sheet. And this is just, I believe it's 16 divided by 38, because 30, let's see, 30, no, I'm sorry, let me take that back. That's 18. 18 and 18 is 36 divided by 38. So 18 divided by 38. Or in this case, when you get and I forget which one, the European one or the American one of them has two green spaces and one of them has only one green space. And maybe this is if you're betting just red or black, it just matters because you're gonna have an extra space there. So in other words, you're not getting a 50-50 chance. I mean, this is a casino. They're trying to make money. So they're not going to just hand out money or give you even a 50-50 chance of winning. They're always going to place it in their best interest. So depending on the number of green spaces that you have. And then I believe last class we calculated the probability of winning for just a straight up come line bet on a craps, right? So that's, I don't know if you guys have ever seen it before, but it's the big place where they want you to place your money, and I think it says come line, and then you get the money there if it's a 7 or 11. You craps out if it's 2 or 12, and then if there's a number that comes up, then you got to try to beat that number before you get a 7 again. So that's the idea behind the come line bet. Anyway, I think we figured it out last time is going to be some kind of probability in that world. All right, so what is a random walk? Start off with some value. So in this case, I don't know, it could be 0, and then you could move up. Yeah, so it's when I said initial here, I mean, and when we get to the casino, we're going to start with $100. But if you were to start off with 0, you could maybe have some probability of moving in the positive one direction or the negative one direction. Again, this number is also sort of fluid in our example that we're about to do. But if you moved up to 1 here, this would be 1 comma 1, right? So after one step, we would be at 1, right? Here, I would be at 1 negative 1. And after one step, notice that you can't get to 1 after 2 steps. So 2, I could be at either 2. So I could be at 2, 2. I could be at 2, 0. Or I could be at 2, negative 2, probably, because it means you lost twice. Just notice that this is sort of a lattice here. If you're using the same amount of bets, if you were, or moving up or down the same amount of place, right? So in other words, this isn't changing to 3 on the next time. It's always +1 or -1. So that's the idea of the random walk, and kind of where you can end up after a certain number of steps. Suppose that we start with $100 and we want to just play a casino game. So many times people will just take $100 into a casino and say, all right, I'm gonna have a fun day, and maybe they just want to know how long they can play before they end up losing that $100. Understanding that the casino's there to make money, they're giving you maybe free alcohol or something. They're doing something to sort of keep you there. Maybe they got some entertainment going on where someone's singing, uh, and maybe you're just sort of entertaining yourself. So you're not really going to go there to try. I mean, I hope no one is trying to go there to make money, because it's probably not a good place to try to make money. It's probably just there for entertainment purposes. But the bottom line is you're going to go there and you're going to expect to lose $100, because that's what you came to play with. And we just want to be able to figure out, well, how many games or how long can you stay there with $100? If you're going to bet 5 every single time, right? So I'm going to bet 5. So I'm going to either plus or minus 5 every single game that we play. And then, oh, by the way, I'm playing the best odds in the casino without even thinking. I mean, you could probably get better odds with other things if you think about them real hard. But if you just want to just go and have fun, well, then the come line on the craps, I believe, is the best probability that we can get in the casino. How often do we win? So in this case, you need to make yourself stop at a certain point, because if you just kept playing until you were done, till your $100 was gone, well, that means that you're going to always lose. But you could be like, well, I just want to gain $40. So if you gain $40, then you're going to stop playing. You're going to go home. Well, I want to know the probability that maybe that we're able to do something like that. Obviously, if you set your value smaller than what you're sort of starting off with, you'll have a better chance of getting to that number rather than maybe trying to double your money. If you go with that one, you're probably not going to. I mean, it's going to be harder to win, obviously, especially if you're playing maybe one of these very red or black games. Okay, so with all that being said, I mean, these are the kind of sort of questions that you can answer with a random walk class, and so that's what we're going to do. We're going to build ourselves a random walk class. The attributes that are the data that we're going to keep track of are, number one, the probability of success, right? So I need to know when I'm going to go up or when I'm going to go down, right? So I need to know if I start off here, I'm going to take a step being an instance of one random occurrence happening, one game of whatever being played. I'm going to either move up or down, and then that number we'll change that plus or minus to be some other number besides just one. Location. So what all location ends up being, and I'll use this example of starting with $100, with 100 at time 0, and there was 0 delta so far. So basically we're just starting off here at 100, and then I suppose that the very first game that I play, I lost $5. And so that would be, so your delta, or the data that you're keeping track of, would be a -5. Obviously you'd go from 100 to 95 and so on and so forth, and your time would increment from 0 to 1. The next time, suppose that we won the next game, right? So I'm a +5 in my delta column. I add 5 to the 95, so I get 100 here, and obviously my time increment goes up to 2, and so on and so forth. You can kind of see what happens here. So you gain 5, gain 5, so you can see the green ones we're gaining, and the delta version, or the delta variable holds the list of numbers that correspond to what the changes were in these. And this is really, the purpose of this is so that I can print these to the screen and I can validate that what we're actually doing is what we intend on doing. The next thing is keep track of time. I don't need a list of 0, 1, 2, 3, 4. I know if I'm at 4, I know this is a discrete event. It's one time step is taken every single time. So if I'm sitting at 4, I know all the numbers before that were 3, 2, 1, and 0. If I'm sitting at 10, I know 9, 8, 7, 6, and that's why you don't need a list of these numbers. That is not true here. These could be all sorts of different versions of ±5. And then finally, the starting location. The starting location is going to allow us to reset. So I'm going to put the starting location at 100, obviously, because that's where we started at for this example, but it could be any number. So that when I hit reset, when I hit the reset button later on, when we talk about doing that, that I know where to put my starting location at. Okay. So those are the attributes, the data. I think that's all we need in order to make this thing work. Again, sometimes you might have to come back in there and update these attributes or add more data to it because you found out that, hey, maybe I want to do something a little bit different. But in this particular case, I think this is where we're going to be, and I believe I developed all these at the exact same time, except for maybe start location. Actually, I think I wanted to reset it, and I came back and said, "Ooh, I need a starting location so that I can put it back to where it started." All right, so the methods that you're going to use in this one, obviously the constructor, you're going to initialize all your random walk stuff, right? So I got to pass in P, I got to probably pass in location. That's really the only two that you need. When you take a step, you're going to tell it what positive and negative delta is and what your step is. The string is going to allow us to validate that the random walk's working correctly. So basically you're going to print out these two lists here, this NumPy array and this list of positive and negative deltas so that you can kind of check them. The repr, the REPR thing is I just want a time and a location, right? The very last time that we where we're at, where our current time is and what our current location is. Again, location is the value that you're sitting at. And then another, so this is already in the Jupyter Notebook. So these methods are already in the Jupyter Notebook, and we will do these in the next video, except for plot path. I'm gonna wait till the very last video to do plot path, but we'll do, and we're also gonna do a run until, because I think that's an important one too, right? So that will answer the question if you wanted to stop at 140, right? So we'll get down there here in a second. So step is just taking a step, or n steps, I should say. So it's gonna take n steps, and it's going to give you, with probability p, you're going to go positive direction. With probability 1 minus p, you're going to go negative direction. So we already know what p is. P is one of our attributes, and then we're going to pass in what positive and negative are. Restart. All right, we want to restart this sucker back to the beginning. In other words, just have this one had to be start at 100, have 0 in here, have time go back to 0, and sort of restart everything, and keep your p or whatever it is. Check 0 is just a simple thing that's going to return true or false if I think we're going to use less than or equal to, but you know, if it's equal to 0, I just don't want to be able to skip over 0. Remember, there's an issue here of coming back. So maybe if these two numbers were different, you might be able to slip by 0 and go into a negative. And we just don't want that to be able to happen. So check 0 will return true or false if you're less than or equal to 0. Length is just going to give me the number of steps that we're taking. Run 0 is going to run until it gets to 0. So in other words, it's answering that question where how long can we play? And then call, I don't think we ever use this anywhere, but I'm just allowing it to call R, and it's just going to return me wherever our current location is. It's not that big a deal. It's just a little bit of functionality. I think I just wanted to add that method just so you guys can see, you know, maybe, and we could add functionality. We could say like call of R of 3, right? So I could do that where it returns the location 3, right? So when time's equal to 3, what was our, so if we go back up here, 0, 1, 2, 3, maybe it would return 105, right? So maybe this one would return 105. Now I didn't put that functionality in there. I'm just telling it to R, and then I'm only passing in self, so you don't pass in anything. Just do that, and it returns whatever your current number is. Not that big a deal. Again, just adding a little bit of functionality. And then this run until, it's gonna look a lot like run 0, except I'm gonna have an extra thing that checks to make sure that we're not past 140, right? So that's all that sucker's gonna do. Now the plot path will give us this graph that basically, you know, over time, what does my thing look like over time? It's gonna, be a lot of squiggly lines in here. Here, let me get ready. Going to look a lot of squiggly lines in here, and then I'm going to have the amount of time I was above the starting location, the amount of time I was below the starting location, and then maybe a histogram in here, right? So a histogram of all the values that are in my data. And that's it. That's what we're going to do. We're going to do that next lesson or next video. Hopefully you guys got something out of this one, and we will start programming next time. All right, talk to you later.